Hello all. In this video, we will be learning about micro robots. So the very first topic which we are going to learn here is the arrayed actuator principles for micro robotic applications. So we know very well that micro robots are like small robots which are used for medical applications, specifically for medical applications and also for defense applications. Usually, robots will be used for purposes where human life is valued much. So, the method of developing robot is called as robotics. When we make it in small size, when we minimize the form, then we say it as micro-robotics. So, this we have learned already. So, usually, micro-robotics size will be in micrometers or even in nanometers. Specifically, micro robots will be used in operations like angio for the heart surgery. So the micro robots are mainly developed using a technology called MEMS, micro electromechanical systems. So when we combine the electronics field as well as the mechanical field to develop the small sized or the miniature components, then we say it as micro robots. Usually, for developing a robot, we will be having devices like sensors to sense the environment. For human beings, we have the sense organs like touch, nose for smell, and eyes for vision. So, for the micro robots or even for the robots, we need to give some special type of sensors so that they can analyze the environment. So, that is the main purpose of giving sensors for the robots or the micro robots. So, these sensors are like input devices. For a computer, we have input devices like a keyboard, a mouse. So, these are the input devices. The output device for a computer is the screen or the printer is the output device. Likewise, for a robot, we can use displays to display the output, and everything has to be processed inside the micro robot. For a computer, we have the central processing unit, which is nothing but the processor where all the data will be processed. Likewise, for a micro robot, we have processors and microcontrollers. For human beings, we have brain to think what we have to do, what we should not do. So that is the main purpose of brain in human beings. Likewise, there is a device which has to be used in the robots as like human beings. So these brains for the micro robots are called as the microcontrollers, or even we can say it as processors. So so, as human beings have a brain, they used to think what I have to do, I should not do. They used to think. But for a robot, it's like totally programmed. Everything is going to be programmed completely. So, if it is a washing robot, then it will only wash. If it is a cleaning robot, it will only clean. So, for a washing robot, the program in the microcontroller will be only for washing purpose and it cannot sense the environment. If it is a moving robot, if I want the robot to move for a long distance, okay, just it want to move only for locomotion means I have to sense the obstacle. That is the only purpose of the robot here. So obstacle sensor should be there. If it senses an obstacle, it has to turn back towards the right side or towards the left side to sense the environment. So that is the main purpose of the robot here. So based on the purpose, every robot will be designed. So for example, in micro robot also the same type. The robots can be designed for only one purpose. So the thing is, it's like it is quite costly compared to developing a robot because it is everything is smaller in size. So our topic is like arrayed actuators which means that if I want my robot to move from one place to another place, then I have to have an actuator or the motor, which is mainly used for locomotion. So we human beings have um, legs, hands, which is mainly used for locomotion. So we have knees, we have joints, we have elbows. Likewise, in micro robots or as in robots, we need motors for the locomotion. So it's like knees and elbows. So if I'm developing an arm as a robot, okay, so for that arm, the elbows should be embedded with motors. So what type of motor I'm using, whether it is a stepper motor or whether it is a servo motor, whether it is a DC motor, that is totally based on the application. That is totally based on the budget which I'm using. So, motors are of several types. In spite of using the word motor, I can use the word actuator. So, if I'm developing a very big robot for very big application, then in that case, I need a series of actuators or series of motors. So for example, I have a joint here, I have a joint in the elbow, and I have a joint in the wrist as well. So three joints are there in my arm as a human being. But if I'm developing a robot for an arm, or if I'm developing a armed robot, maybe for painting or maybe for pick and place operation or maybe for palletizing operation, I need three types of motors to work as an arm for the robot. So these types of three motors, I have to connect it with a driver. Okay, so only one driver which can actuate and give connection uh, to the motors. So driver is connected with three motors in this case. So these types of motors or the actuators, we say it as micro actuators or arrayed micro actuators. So this is the main purpose. Here we have an actuator. This is the diagram of an actuator. So every actuator needs to be powered. It has to be given a power supply. So this is a micro actuating element. So we have a transconduction unit, which means the programmer. This microcontroller or the programmer will be connected with the driver and with the micro actuator. So based on the program, the actuator will work. So if I want, I'm deciding, I'm a human being, I'm a programmer, I'm deciding where the robot, for how long, for how much distance the robot arm should move to pick the object. So to take it, to lift it up, to hold it up, lift it for open your end effectors or the fingers. Open the end effectors, hold on to the object, lift the object for 5 meters, turn to the left side, bring it down, and leave your end effectors. I have to give all these steps as instructions for the robot. So it's not like a human being. So like if I say my child to pick the stone, she will pick. But in case for a robot, I have to give all these steps as instructions. All these are performed only because of the micro actuators or the motors. So here we have a picture of the micro actuator. Here we have the block diagram of the micro actuators. Usually the electrical energy is converted into mechanical energy in case of micro actuators. For example, I have a robotic setup. Uh, so an object is there, an object has been sensed by the robot. That sensed information is an electrical information which is sent to the microcontroller, and then the microcontroller gives the instruction to the um, actuator or the motor to pick the object. So every electrical signal is converted into mechanical motion, which is called as the micro actuator. So here we have the block diagram of arrayed actuator. which means that, as I told already, series of actuators connected together to perform a very big task along with a microcontroller. So that is called as a arrayed actuator. So matrix or a linear pattern, these types of connection can be in a linear pattern, as like my arm. So I have three joints in a linear, in a line, okay, in an alignment. Likewise, I can fix my motors in my robotic arm in a linear pattern, or it can be in a matrix pattern. So that is totally up to my choice. So the main purpose why we are learning micro robotics, why do we need a micro actuator? So this is called as an empathy. Why we have to do this? What is the purpose? Why am I doing it? That is called as an empathy. So whatever we learn, whatever we want to know, we have to know the empathy or the purpose of the study, which is very important. So actuators are mainly for locomotion. If we are doing it in a nano scale, or if we are doing it in a micro scale, then that is called as a micro actuator, or even the nano actuators are there. So these are very smaller in size. These can be used in healthcare operations. It can be used in environmental operations. And so this is again a block diagram. So the path of the robot will be designed or finalized by the microcontroller or the program. So which path the robot arm is moving? So that will be given as a feedback to the microcontroller again. So every microcontroller movement, every robotic arm movement will be given as a feedback uh, to the microcontroller. So it can be a visual feedback, that is totally up to my choice, the programmer's choice. So it can be a visual feedback. The robot arm is picking up the uh, toy. The robot arm is lifting it up for 5 meters. The robotic arm is turning towards the left side to keep the toy again, to keep the toy below. So these are like displaying information which if I want to display, I can display, or else it's not needed. So these are the types of feedbacks which I can give it back to the microcontroller. So here we have the block diagram of arrayed microcontroller actuators. So here, this is called as a magnetic actuator. There are several types of actuators. Few of the actuators which I told are like stepper motor, servo motor, even magnetic actuators are there. So here we have camera and microscope to analyze the environment. So these are like sensors. Even a camera is called as a sensor. So the images will be processed inside the image processing. We have a processor which is nothing but the computer where we will be having commands like motion commands. We will be having the algorithms for controlling the sensors, and we will be having commands of what to do. We will be having the display. So these are the uh, overall block diagram of the microcontroller in the in the robot. So these are like industrial applications where the micro robots or the robots can be used. So the next one is like the medical applications. Micro robots are specifically used in medical applications. If I want to do a documentary about animals, about a particular forest, if I'm doing some PhD work in forest documentary about a particular species of animals, if you want to know, I can use robots, micro robots. So for analyzation purpose, even in aerospace technology, I can use this, and also even in automotive industries. So here we have a assessment of the MCQ. Micro robotics primarily deals with. So we have four options. The first one is like robots operating at a nanoscale, robots designed for large-scale industrial tasks, robots functioning at the micro to millimeter scale, robots used in space exploration. So there are four options. So if you have an answer, comment me below. And yeah, so these are the reference websites which I have followed. to make this PPT. I hope you have learned from the video. See you in the next video. Until then, I say bye bye from Radhika.